Hi everybody. So let's solve the first variation on this problem. Same setup. I've got a ball that starts here, is rolling to the right. Its diameter this time is 3 feet. But this time, I'm not telling you that it makes a full revolution every certain number of seconds. This time, I'm telling you that its horizontal speed is 2 feet per second. So let's set it all up again. And the whole trick is to ask ourselves, what information were we given and what information do we need to make the equation that we have? So following the story from last time, I still have this vector that sticks straight up, except now the diameter is 3. So the radius is 1.5. And then I've got this vector that stretches to the right, but I need to know how fast it's stretching to the right, so I need to know the horizontal speed. And then I need to know the rotational speed for the rotation part. So I'll leave this part empty for the moment. Okay, so there's two things that I want to focus on. What's my horizontal speed and what's my rotational speed? In the last version of the problem, we were told the rotational speed, but not in radians per second. We were told it in revolutions per second. But this piece of information was really just telling us how fast we're turning. And we had to calculate like what was the total horizontal distance we moved in how much time. This time I'm telling you the opposite. I'm telling you that you are moving at 2 feet per second. So that's my literal horizontal speed. If I'm rolling, but my horizontal speed is 2 feet per second, I can just make this 2. Because if you imagine plugging in t as 1 second, this is a horizontal distance of 2. If I plug in 2 seconds, it's a horizontal distance of 4. So whenever I increase by 1 second, my total horizontal distance increases by 2. So that's already used that piece of information, and now I'm done. Okay, but I still need to know my rotational speed. So let's see, rotational speed, that would be like radians per second, for example. So to do that, it would be really helpful if I knew, I know it takes one full rotation to go the circumference. So if I could figure out how long it takes me to move that far, then I could figure out that's how long it must have taken to do a full rotation of 2 pi. So let's figure that out. The circumference is going to be 3 pi. So I know this distance here is now 3 pi. But the problem is I don't know how long it takes me to move that 3 pi. But we can solve for that because I know I'm moving at 2 feet a second. So I know that moving at 2 feet a second times some amount of seconds is going to end up at a distance of 3 pi. So in time is 3 pi over 2. That's how long it takes me to go this far. And I know that that's also how long it takes me to do a full rotation of 2 pi radians. So my rotational speed is going to be 2 pi radians divided by that amount of time it took to do the rotation. So here, if I take the reciprocal and multiply, that's like 2 pi times 2 over 3 pi. So the pi divides the pi, and that gives me just 4/3. So now I've got, let's plug in 4/3 t and think if this makes sense. I guess since all the rest of the problem is the same, I still want my angle at time 0 to be pi over 2. So let's go ahead and add pi over 2. And as time increases, I still want my angle to decrease because I'm going from pi over 2 towards 0. So I still want a negative sign here and here. So let's now test to make sure this all makes sense by plugging in some values. At time 0, my angle should be pi over 2. And if I look at it, that's what it's going to be. Because at time 0, it makes this negative 4/3 term become 0. And my angle is just pi over 2. So that's good. So then I know that it's supposed to take me this amount of time to go one full rotation. So what if I plug in that time? If I plug in 3 pi over 2 as t, let's calculate what I get. I get 3 pi over 2 times 4/3. So let's see, the 3 divides the 3, and I'm left with 4 pi over 2, which is the same as 2 pi. So that means at the correct time for having gone this distance, this part is 2 pi, or rather it's negative 2 pi, but then I still have this pi over 2, but that's what I want because it started at an angle of pi over 2, and then if I subtract 2 pi, that's like subtracting a full rotation, which is exactly where I want it to be pointed at the end of the distance that should have been a full rotation. So I checked, I plugged all the things in, makes sense, seems to work. So that would be the solution to that problem.